Hey, what is up everyone, and welcome back to another video. I'm really excited for this video today. In it, we're going to solve real-world data science problems with Python Pandas. So basically how it's going to go is we're going to take a data set, do some initial processing and cleaning of that data, and then once we have a little bit more of a polished data set, we're going to start exploring that data and really using Python Pandas and Python Matplotlib to extract meaning from that data. And ultimately with that kind of extracted meaning, with that analysis, we'll be able to answer real-world business type questions from the data as a data scientist or a data analyst would. Before I begin, I want to say thank you for making this happen. I started with this video as a poll of 4 options. You guys apparently liked this option. So it was overwhelmingly the highest voted. And then I asked the question, what should I include in this video? And you guys gave me all sorts of really cool responses. You gave me too many responses, and I'm not actually going to be able to put everything that you guys suggested I do into this video, but I'm going to make this a series. So if you find you like this video, make sure you subscribe so you don't miss the future series. I know some of my ideas for the future kind of real world data science problems will be sports analytics, going to be maybe stock trading analysis, maybe some specific Kaggle challenges you guys find interesting. I think it'll be a fun way to do a bunch of different videos and a bunch of different real world data analysis stuff. So hopefully you guys like this video. Okay, to get started with this tutorial, you'll need to download the data. So you can do that by going to my GitHub page, which is linked to in the description. And the data is found in sales analysis, sales data. So that's 12 months worth of sales data right there. So go back to the home directory of the GitHub page. And there's 2 options for getting the data. So you can either, if you're familiar with Git, you can either fork this repo, then clone it locally. And instructions on how to do that are within the setup of this repo. And the other option is to click this green button up here and to download the zip. And then go ahead and extract this to wherever you want to work on the code. So I'll put mine in a place like YouTube code/data science, and I'll select that, extract it. And then I recommend next, I personally like using Jupyter Notebooks to do my analysis. So I'll open up a Jupyter Notebook. And I do this by going if you don't have Jupyter Notebook, I'll put a link to set it up and how you do that in the description as well. So check that out. And I like Jupyter Notebook because you can kind of you can write your code and really show a nice analysis that you can kind of give to someone else all in the same place without any extra effort. So that's why I like Jupyter Notebooks. Okay, so go to this and sales analysis. And as you can see, there's already a finished Jupyter Notebook there. That's the completed code. But we're going to create a new Jupyter Notebook to just kind of start from scratch. And I'll call this just analysis. Throughout this video, I'm going to present kind of concrete tasks for you to try to solve. The way you're going to probably get the most out of this video is each time I kind of present a new task, try and solve it on your own. And then if you can't figure it out, go ahead and play the video and then I'll walk through the solution. You don't have to do that, but I just think it's a good recommendation to get some real hands-on experience. Okay, to get started, let's import the necessary libraries we need. So to start, it's just going to be pandas. And if you don't have Panda installed, I'll put a link into the description to install pandas. All right, so what is our first task? So the first task is going to be we have, in that repo, we have all that data that I showed you. So we have the sales data folder, and each one of those, and in this, there's 12 months worth of data. So the first task is going to be merging 12 months of sales data into a single file. So go ahead and try this on your own, and then I'll go through how to solve this. And we want to do this because it's ultimately going to be easier for us to do all sorts of yearly analysis when we have everything merged together as opposed to 12 separate files. Okay, to do this task, I would say to start simple. And to start simple, let's just try to read a single month of data. So if you remember our data, we're currently working on an analysis file. And our data is in sales data, and then let's say we wanted to get sales April 2019.csv. So we can do that by using df equals pd.readcsv. Dot slash is our current directory, and then it was sales data / sales April 2019.csv. So this should get us just a single month of data. Run that. Oh, and then if you wanted to actually see, I ran it with Shift plus Enter, by the way. That's how I did it quickly. df.head will give us the first 5 rows. And as you can see, look at that. We got, you know, a couple products ordered, the order dates, the purchase address. We have our data. Cool. So now how do we take that and actually take each month and merge it into one? So, I mean, whenever I'm solving something like this, I'm usually doing a bunch of Google searches. So, I mean, Stack Overflow is our biggest friend when we're solving these data science problems. I don't remember half the things that I feel like I end up using, but I'm able to know what I'm looking for and search for it. So, you know, you'd open up like a Google window and type something in like read all files from directory, Python. How do I list all files in a directory? Let's see what it says. os.list directory will get you everything that's in a directory, and it gives you an example. Look at that. Cool. So we can use list directory. I'll import it like this. We'll import it up here, and I'll rerun this so we get all of our imports there. And then what we're going to do is for we'll do files. Let's say files equals, and we're going to do a list comprehension here. We're going to say file for file in os.list directory. And I believe we can pass in a path here. So we're going to do sales data. And hopefully that files will give us everything we're looking for. So now I'm going to do for file in files. No, that's not what I wanted to copy. We'll just say print file and see what happens. And now I'm going to get rid of this df.head here. Look at that. You get the 12 months worth of data by doing file for file in os.list directory. So now we just need to take these files and concatenate them to make a single CSV. So how can we go about doing that? And, you know, I'm doing the same thing here behind the scenes is, you know, I'm saying, you know, how do you concatenate data frames? Or, you know, maybe you don't know the word concatenate, maybe you say like a merge or something. Like you're probably gonna get to the same answer in pandas. Pandas.concat. Okay, this looks helpful. So, you know, I might search through the documentation and now we're ultimately gonna concatenate them into a single CSV. Okay, so we're gonna start out and I'm gonna just say something like all. Before we go into the for loop, we're gonna probably want to define an empty data frame to kind of store all of our data. So we're going to say all months data equals pd.dataframe. So this is when we read the CSV, we read it in as a data frame. So if we wanted to create an empty data frame, we'd do something like this. And now what we're going to do is each time we add a new file, we're going to have to read the file name. And remember, we start it with this path. So we're going to ultimately do print, or we're going to move this read CSV into here. We're going to do df equals, we can honestly copy this whole line. df equals pd.read CSV. And now instead of this, we're going to do sales data slash plus file, because that would give us the same thing, because each time we do this, we'll get the appropriate file name. So that should read all of the data frames, but now we need to append those to the all months data. So we can do that by doing all months, and you know, there might be multiple ways to do that. This equals pd.concat, and we're gonna concatenate all months data before and the result of our current data, so df here. All right. And then when we get to the end, it should have concatenated each month because we iterated over each file, and we should get, we can do all months data dot head and see what we get, see if anything works. I mean, it ran, so now it's a matter of did all months data, can we save it and does it have everything? So I'm going to do a to CSV. I'm going to do all months data dot to CSV, and if you're not familiar with some of these commands, I definitely recommend you check out the first video I posted on Python Pandas. I'll pop it up above me. It will cover all of this stuff. So I'm going to do all data. I'm going to call it all data.csv. And I'm going to do index equals false because I don't want to save this first column of values. And let's see what happens. So it ran, and now do we have all of our data? Moment of truth. Okay, so I'm going to go back one directory, all data.csv. Okay, that looks good. So I'm going to open it up real quick, whatever, okay. Load, 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 load. Okay, so we have April, it looks like. That's 4. But now if I scroll down, do we have the other months? Moment of truth. Oh my god, load. Why are you so slow? Ah, I see 8. Yeah, I mean, we have the months here. You can scroll through your data to double check, but it looks like we have everything here. So this is a good starting point. And I quickly recommend to add a column to read in the updated data frame so you don't have to run this every time that you want that all data file. So we can do that by just doing all data equals pd.read_csv all data, and all data head will show us the first 5 rows. And as you see, we have everything in this all data. So that's the updated data frame. All right, so now that we have all the data in one place in a single data frame, let's start doing some analysis. So the first question I want you guys to answer is going to be this. What was the best month for sales in all of the data? And how much money was earned in that month? And we're going to break this down a bunch before we do it, but feel free to try to solve this full question on your own. But I'm going to break this up into a couple smaller tasks. So let's insert some more cells. Basically what I'm going to recommend is before we do the best month for sales, let's augment the data with some additional columns because that will ultimately be helpful in our analysis. So the first thing is right here we have an ordered date, but we don't easily have the month. So I think that we want to add a specific column for the month. So I'm going to just call this little section that we're adding augment data with additional columns. And we're going to add a couple more. So insert cell below. I'm going to just add a couple cells because I want a little extra space to work with. Okay, so we want to augment the data with some additional columns. That's one thing we want to do. So the first column that we want to add, and I'm going to just kind of nicely label all this, is a month. So I guess this is kind of like task 2. Add month column. Okay, adding the month column. So with this and kind of anything in Python Pandas and Python in general, there's multiple ways to go about how we would add a month column. It's kind of a balance of what's easiest versus what's like easiest to read versus what's most scalable, etc. So looking over here, we don't have the month currently, but we have dates for each of our products that were sold. So immediately what comes to my mind as the easiest solution to add a month column would be to just take the first 2 first 2 characters in the date string and make that the month column. So that's what we'll start out doing. So, okay, how do we do that? And if you at least have an approach and know what you're trying to do, usually you can use Google to your advantage and just search how to do the specifics of that approach. So to add the new column, we can do all data month. We could say something like 3 to start, right? If we wanted to, just to show that we can easily add a new column like that. As you see, month, everything's 3 right now. So that's okay, just adding a number. But we want to add the proper date, reading from the order date column. So to do that, we can do all data, and then we're going to grab the order date. And then when we want to convert this into a string, we can, get the string properties of this cell and this whole column, we can do .string. And then we can access it just like we can access a normal, Python string. So I can do 0 to 2, and that will grab the first 2 characters. And honestly, I think that should be good. So let's see what it looks like in all data head. Look at that. So it looks like we got 4th month everywhere. The one thing that I have an issue with right now is it's definitely a string here, and I think that a month should probably be a numerical value. So to do that, we can kind of pretty straightforward do some conversions. So I'm going to go ahead and use the astype method in Pandas. So that looks like, so I'm taking that same column we have, and I'm basically just performing a manipulation on what we just saved, so the 04 that we have. And I'm going to do all data month dot astype, and it doesn't really matter what type of integer we use because months are only 1 through 12, but I'm going to just say in 32. And so that should now convert it to numerical values. Let's see if it works. Nope, it does not work. And why does it not work? All right, let's see. Cannot convert float NaN to integer. Fun. So it looks like we have some NaNs in our data, and we're gonna have to clean that up. So before we finish this task 2, let's start cleaning our data. Okay, so let's just create a new section in our little Jupyter Notebook here. I'm gonna add a couple more cells. I don't know how many cells we'll need, but I'm gonna make the first thing here, the main point, to clean up the data. Okay, so the first thing we wanted to clean was that we ultimately had rows that there was an NaN value somewhere, and let's see if we can figure out where that is. So we don't see anything here, but what we could do is maybe display some more data. Maybe let's display like 50 spots, and let's see if we see anything there. I still don't see any NaN. Maybe we go to 100. Okay, it's not even going to show this. What we could do is, okay, so we can't see it by doing this. And you know, sometimes you'll only have like 1 or 2 not a numbers in the tens of thousands of rows. So like, even though you can't immediately see it, like what you could maybe do is like in Excel or something, sort the data and see it. But we can also use Pandas to figure out exactly how many NaNs we have and what they kind of look like as far as rows go. So to do that, let's, I'm gonna real quick just write up a markdown cell. We wanna drop rows of NaN. So to do that, let's first figure out if, you know, we have where our NaNs are. So I'm gonna just call something NaN DataFrame. And we're just gonna use this to kind of filter and get all of the NaN rows that we have. And we don't know exactly where. I don't know if our error message told us where it was. I guess it's probably because we're trying to convert this month to int. It's gonna be in the month column, but maybe it's other places too. So how do we get the not a numbers? We can do a handy dandy Google search. And let's see, let's say find rows with a NaN pandas. How to select rows with 1 or more nulls from a pandas data frame. Okay, Stack Overflow will immediately probably tell us. Let's see. Is null, or maybe I'm going to say instead of select rows with, oh, it looks like I already clicked on this one. Display rows with 1 or more NaN values in a pandas data frame. You can use dataframe.any with parameter axis equals 1. This looks probably good to me. Let's try this. Okay, so this is the command. I said we wanted to call it NaNDF, so I'm going to just delete this literal part. And our data frame is not called data frame, it's called, or DF, it's called all data. So we can do replace this with all data, and hopefully this Stack Overflow post helps us. And if we do NaNDF, we can .head, we can see what our NaNs look like. And look at that, they are a full row of NaNs. So basically, it's not like we're just needing to refill a single order date value, like we're missing it. We have rows that are completely blank. So let's just try to go ahead and drop all of these rows. To do that, we can use a command called drop NA. And just like I kind of found this command, you could also do a Google search and figure out how to drop the NANs. So let's see. We have all data, we're going to say, or let's just, yeah, all data equals all data. And we can do drop NA. That's going to be the command. And if you look up the documentation for drop NA, there's there's a parameter called how. And you can either do any, which would drop a row if it just had a single NaN, but maybe it had all these as normal values that were filled in. But in our case, we found a bunch of these rows with all values that are NaNs. So instead of doing drop NA any, we're going to do all. And let's see what happens now if we set all data to this value. And I'm going to just all data.head. Just see if, okay, it looks good. But our real test will be if we run this and try to convert the month column to integers, will it give us that same cannot convert float NaN to integer error? And this is the moment of truth. We still get an error. Please not be the same error. Invalid, oh, look at that. Different error. Invalid literal for int with base 10 or. So now we need to figure out what we need to clean up to fix this issue. Okay, so we have this issue, and so let's try to figure out what is causing this or to pop up when we're trying to convert to an int. So let's do that in our cleaning section. So first, let's think about what would be causing that. So we had or, but it's kind of unclear why that would happen. But ultimately, what I'm thinking is that, you know, we take the first two characters and we paste them over here. So my gut feeling would be, okay, some reason OR, the letters OR is in the first two values here. So let's try to figure out where that happens. Okay, to do that, we can also use that that same function that we use to grab the first two string values. We could do something similar to filter this all data. So I'm just going to say temp df for now equals all data. And then we're going to filter this. So you could either do it like this, or I think also location would work here. But we're basically trying to index all data based on a certain condition. So we're passing in a condition here. And the condition we want is that the first two characters of this order date equals OR, because that's what's causing our issue, and that's what we want to clean up. So to do that, we would do something like this: order date dot string 0 to 2, just like we did when we were getting the month, and then we want it to be equal to OR. I just want to see where it's happening, and then we can delete it. Okay, look at this. So we see our issue. For whatever reason, the columns here were getting duplicated throughout our data frame. So ultimately, if we can just drop all of these types of rows, hopefully we have no errors after that. So we filtered all data by the values that equals OR. Well, to get the values that are not equal to OR, we can just change this equals equals to a not equal. And instead of making this temp data, we'll just reset it to be all data. So now if we do this, we'll get a new all data. And if we're lucky, this new all data that has now dropped the NAs, and we've got rid of the duplicated column headers that were scattered throughout the data frame. Hopefully now we can add our month column and convert it to an int with no issues. Nice, we did it. But okay, so now that we've added the month column, let's revisit the question that we were trying to answer. What was the best month for sales and how much was earned that month? So we've now gotten something that will allow us to easily filter by month. But the biggest other question that I see in this question we're trying to answer is sales. And while we have the quantity ordered and the price of each, ultimately to get the sales values, we'll want to like multiply this by the price of each and get like kind of like a per order sales value. So let's add another column. So I'll kind of make this task 3. Add a sales column. So this will ultimately help us get to really actually answering this question 1. So add a sales column. Well, how do we do that? This is it should be fairly straightforward. As I said, quantity ordered time price each will give us our sales. So we just do all data sales. We can say that equals all data quantity ordered. And we can do it, there's a nice syntax here where we can just do a multiplication symbol and then do all data price each. And if we then print out what our data frame looks like, what the heck? Okay, can't multiply sequence by non-int of type string. So looks like we actually have a little bit more cleaning to do. It just appears that, the reason we're probably having strings is that even though these look like numbers, they're actually encoded as strings. So as a additional thing, let's convert columns to the correct type. So we'll start with the 2 that we were just trying to deal with. So we want to make all data quantity ordered. We want to make that a type of int. So make int, and then we want to do the price of each, as we see here. We want to make that a float. So price each. We want to make this a make float. Okay, so before when we made an integer value, where did I do that? We did, I forget where I put it. We did as type. There's actually another way we can go about making numerical values in pandas, and it's called pd.toNumeric. And it handles a little bit more because you don't have to like fine-grained say you want an int32. It'll kind of just figure out what the correct type is that you should convert it to. So we're going to use that here to convert our columns to the correct type. So we're going to just do pd.toNumeric. And really, I'm going to keep reiterating this, but when you're doing this analysis, as long as you have like a idea in mind of what you want to do to the data, so like here we want to convert it to a numerical type, if you use Google to just try to figure out the exact way to do that, you're usually going to have luck. So it's really just a matter of being able to have the logical thinking to like know what you want to do to the data, because finding the syntax is usually pretty accessible via the great old internet. So pd.toNumeric, and then we'll pass into that all data quantity ordered. I think this should be the syntax we want, and we'll do the same thing to the price each here. Okay, let's run that and see what happens. Well, we got no errors. Let's just print out our head. Okay, looks the same as it did before. Ultimately, I think we'll really know if we can run that sales column and not get any issues. So let's see if we add a sales column by doing this. Look at that. 2390 is 2 times 1195. So it looks like we got what we want. If you wanted to, you could reorder this column over here by the quantity ordered and price each. I'm not going to go through how to do that here, but I did cover that in my previous pandas video, so you can check that out if you're really curious. Ultimately, it doesn't really matter where our columns are positioned when we're performing the analysis, so I'm fine just leaving it over here on the right side. All right, now that we've successfully, added our month column, added our sales column, let's finally answer this question. What was the best month for sales, and how much was earned that month? Well, we can do this pretty easily with a group by function. So we'll take all data. We will take group by. Well, we want to figure out what's the best month. So we can just group by the month column. And then what we want to do is sum up the values. So we're grouping by month and then summing. So let's see what happens if we do that. Well, we get 12 months, and we get the sales values over here. And if we just wanted to look at the sales values, we could type in sales up here. And as you can see, I don't actually like that as much. Let's go back. Now we can answer our question. And so what was the best month for sales? Well, as you can see here, December was the best month for sales with approximately $613,000 in sales that month. And then worst month was January with $1.8 million in sales. And if we wanted to, we could also plot this, because I think plotting oftentimes is a good way to visualize these results and kind of see the trends month to month, and maybe do some further analysis on maybe why is certain months higher than others, and it's easier to see that than in this chart. So we could do import matplotlib.pyplot as PLT, and I might go a little bit quickly through this graph, but if you want to know more about Matplotlib, feel free to check out the 2 videos I've posted on the library. They should probably walk you through everything. But we want to do a bar chart. I think that will be good for this data. As our X value, we want all the months. So I could get the months probably in a couple ways, but I'm going to just do months equals range 1 to 13. This 13 is exclusive, so this will actually get me 1 to 12. That's what we want. So I'll pass in months as my X value. And our Y value, well, that's going to be this sum value. So maybe we just say results equals all data group by .sum, run that. And then we're going to pass in results as our Y value. And we don't want all results. We want just the sales column as our Y. So I'm going to do results sales because we've saved it as that data frame you saw before. And let's see what happens. We have to do plot.show. Look at that. We got all of our months and the number of sales. Well, we might want to make this chart a little bit nicer. So we could do a bunch of different things. We could do first plot X ticks. I want to see every month here. I think it'll just be easier to visualize. So I'm going to do plot.xticks equals months. I'm going to do plot. I'm going to add a Y label and an X label. So Y label is these values over here. So that is the sales in US dollars. And our X label is the month label or the month value. So I could just say something like month number. And if you really wanted to get fancy, there's the date time library in Python that you could actually convert these month numbers to their actual named month. But I don't think it's necessary for me to show that right now. But look at that. So we got our month number, we got our sales in US dollars, we got these labels, and you can see the relative thing. So worst in January, it goes up, then dips, then goes up. And as a data scientist with like these results, I would try to like figure out, why were certain months better than others. Like, in the 4th month in April, did we maybe spend more money on advertising? I would try to look for the correlations that, probably led to these better results. So like in the month of December, if I'm thinking about it, like why would we do so much better in December? But if you kind of think about the U.S. holidays, they're international holidays, but like the big thing in December is Christmas. All the holidays, people are buying a lot of gifts for each other, so it makes sense that December has the most number of sales. That's like very, that definitely like checks out to me. And maybe everyone's done spending money by January. So this is the types of things we're kind of like figuring out from our data. Okay, so now that we've answered question 1, let's ask another question. And I'm gonna just make a bunch of cells so we can kind of start fresh. And I'm doing shift enter every time that I make a new cell. You can also do control enter, and that runs the code and keeps you in the same cell. Nice things to know. But okay, so what is our question 2 gonna be? And I'm gonna say question 2 is going to be, what US city had the highest number of sales? So this is very similar to the first question. So maybe you can try to answer this one on your own. And as a hint, you're gonna have to augment your, I would recommend at least to augment your data with a city column. So you have to figure out how to do that. But what city had the highest number of sales? That is the question that I'm going to ask now. Okay, so yeah, the first step in solving this is to augment the data. So we're gonna go back to our augment data stuff. I'm kind of forgetting these task numbers, but okay, I'll say that this is task 4. Task 4, add a city column. Okay, and we need to enter one more cell below. Okay, so add a city column. So how could we do this? Well, where do we get our city from? Well, if we look at our data, we do have a purchase address, and nested right in the middle, unclear how to get that exactly, is our city name. So if we want to sum up by city, we're going to have to somehow extract this value. So how are we going to do that? My solution to grabbing the city column is to do one of the most useful, I would say, functions in Pandas, and that is the apply method. So let's use the .apply method. And basically what this .apply method does is it allows us to run any function on our data frame, and I'll show you what I mean in a second. But okay, so whenever we're making a new column, we can usually start out by like doing all data or whatever our data frame is called, and then just create the new column name and say that equals, what does it equal? Well, it's going to be somewhat related to purchase address. So if we go ahead and do all data purchase address, that's a good start. Okay, so what do we need to get from the purchase address? Let's look at how these are structured and try to be very programmatic about it. Okay, so we have, this address. One thing that I immediately see is that Dallas is between 2 commas. So what we could do is split on the commas, and then we're going to get Dallas a lot easier. So we want to split each of these strings. So basically perform a function. We want to write a function, let's say, and have it split and get Dallas, which is right in the middle. So to write this method that I just kind of described, we'll use the apply method. And basically this allows us to apply kind of an arbitrary function on an entire column or on several columns within a data frame. So apply, I'm going to do lambda x, and I'm going to say, just to start, I'm going to do x dot split by comma and grab the, I guess if we split it on commas, we want not the 0th index, but we want the first index because that's how we count in Python. So I'm going to just show you what happens when I do this. Actually, we'll do head. Okay, look at that. We already have our cities right here. And what this is doing is saying for every x value, so when we do apply, we can use this lambda x, and basically the x value here is the cell content. So we're saying for each of these cell contents, we want to split it by commas and then grab the first index. And one thing that's really nice is that we could define a function like get city that would take in some sort of address value, and we could return basically what we just did with this lambda function. We could do address dot split dot comma, or with a comma, and then grab the first index of that, and that's what we just did here. But I could then replace this with get city x, and now we can define any functions we want with this apply method and ultimately run it within our data frame on a column. So we can do all sorts of really crazy, like we could get super, super crazy with this function and do whatever we wanted in it, and use apply to basically incorporate that into our data frame. And I think the one caveat, critics might have of this apply method is it's not going to be the most efficient. You might, because this is a custom function, it can't be super, super highly performant. But honestly, like for most cases, as long as you're not dealing with, hundreds and thousands of like terabytes of data, like for most, everyday data science use cases, I have no issue using this apply method and with speed or anything. So I'm going to run this again and show you that it still works properly. And just to real quick clarify, the reason we do lambda x is basically whenever we do lambda x, this allows us to grab the cell contents. We could apply other functions in here that don't depend on the cell contents without using a lambda function, but whenever we need to actually do something on a cell's content, we'll use this lambda x notation. And real quick, I just noticed that I named this column instead of city, so I can change this to city. And oh no, now I have column and city. We can drop that column, named column, by doing all data.drop columns equal, and then the one we want to delete, so that's just column. And now if we do it, and then we also, this would do it in a separate spot. So if we want to set it to back to all data, we can do it like this, or you can also pass in the so I run that and it works. I also could have passed a keyword in place and said that's true, and that would have done it without setting it there. But okay, now we have just our city that we wanted. Moving forward, I have a question for you, and I think this is a pretty tricky question, so I don't really expect you to get it, but if you can get it without me giving you further hints, like huge gold star you guys get. But is there an issue with just listing the city here? So we want to aggregate all the city totals and sales, and I'm asking the question, do we have any issues by just doing it how we did it? So, we have these addresses, and I'm wondering, do we need to include anything else, or are we good? Like, will we run into any issues down the road? So try to think about that for a sec. And to answer the question, yes, we will run into an issue. If you think about, U.S. cities or cities around the world, there's a lot of duplicates. So, I'm here in New England, and, when people say Portland, I'm thinking they're talking about Portland, Maine. But when you talk to someone on the West Coast of the United States and you say Portland, they are most certainly not thinking of Portland, Maine. They're thinking of Portland, Oregon. So in our data set, we actually had the overlap in cities with those two cities I just mentioned, the two Portlands. So we should also grab the state. So we can write another function that takes in an address, and from our address here, it's going to grab this state value. So that's not going to be too crazy. We can do the same start values. We can do address.split. We can split it on commas, and now instead of the first index, we're going to grab the second index because that contains the Texas stuff. So do second index, and we'll just, for now, we'll have this leftover zip code, but we'll just include that in our answer for now. So if I wanted to show you that, I could do like get city plus empty string plus get state address, and we should have something a little bit more complex in that city column. No, what had happened? Oh, it should be address. It should be X here. And as you see now, it has like the state plus the zip code. Okay, so how do we get rid of the zip code now? Well, we can do another split, and this time on white space, because there's white space between Texas and 75001, and then we can get the white space here. So we're looking at the white space here. There's white space before Texas and white space after Texas. So again, this we'll want to get the first index here. and I'll run that. Look at that. Dallas, Texas, like that. That's cool. And real quick to see, like, what would have happened is that basically because there's white space on the left side of the state abbreviation, when you split on the white space, you'd ultimately on the left side of this have an empty string, and that's what's happening if we grabbed the second index here or the 0th index instead of the first. Cool. So yeah, Dallas, Texas. And if you wanted to format that a little bit different, a couple of ways you can do it. So you could maybe do plus space, parenthesis, and then plus parenthesis like that. And then that's maybe a little bit nicer of a syntax. Another cool thing you could do, I'm jumping around all sorts of topics, but there's a concept in Python called f strings. So basically I could also do an f string of this whole entire thing. And basically whenever I have a variable, I surround it with brackets. And then I don't have to do the pluses anymore. The pluses are now just part of the string. So I could do parenthesis and then another bracket because we have another variable here with the get state. We're executing code. So whenever we execute code, we use brackets in the f string. And then we get rid of the plus, the quotation here. And we've just reformatted this in a, let me scroll down so you can see it, this in a different fashion. So if I run this again, we should get the same exact thing. Look at that. And f strings are, I think, a addition in like Python 3.5 and higher. So as long as you're using that, you're good here. Cool, we have a city. So let's do the aggregating on the city now. Okay, so now that we have our city column, we can actually go ahead and scroll down here and answer the question, what city had the highest number of sales? Well, if we look at how we did the highest number of, what did the best in a month, we can just kind of copy the syntax. So I'm going to just say results equals group by, and instead of group by month, we're going to do by city and sum that. So let's see what we get for results. So you can either print results, display results, or just leave it as the last thing executed in your data frame. Okay, so we have cities, and as you see, there's the Portland, Maine, the Portland, Oregon I was talking about. And what was the sales here? So this is kind of annoying to like view it nicely. So if you scroll through this, you can see that San Francisco appears to be the best. But I think we should plot this again. Copy basically the exact same code from what we just did. So I'm gonna just copy and paste in from above. So now we're not using months as our parameter. We're using the cities. And our results sales, we want that the same, so that's fine. What else do we want? Y label, that's good. X ticks. Okay, so we really just need to check into our X values. So what are our X values? Well, they are going to be the unique value. So there's this unique command, I believe, that will get us the unique column values for a specific, or the unique values in a specific column. So if I did all data city unique, that should get us, and I made the cities, that should get us all the different cities that we have. So all of this, what you see here. So I can pass this in and make this the X ticks as well. And let's see what happens. Cool, looks like we have a plot. It's really ugly. What else can we do? Well, for X ticks, instead of having it listed out horizontally, because that's what's causing the collisions, and I guess this is not month number anymore, this is city name, so US city name. But what we can do with the X ticks is we can pass in a rotation equals vertical, and maybe we make the font a little bit smaller, so I'll say the font size equals 8. And look at that, we got all our cities. But I see an issue. What did we do wrong? Well, when we did the sum here, we found that San Francisco was the best number of sales. However, when we look at this chart we just made, Austin is the best sales. So what is happening? And I was kind of running through this code before I did some of this tutorial, and I ran into this. I was like, what the heck? Like, why did you break on me? Like, why are you showing inconsistencies? Well, the issue is that when we're showing the Y data, the order matters. But when we do this all data city unique, it orders it in a different way. So our X data and our Y data are not in the same order. So we ultimately need to make this stuff be in the same, the cities be in the same order as the sales results. So to do that, we can do a list comprehension. This is something that I found on Stack Overflow, but basically what I found was you could do city for city, DataFrame. Basically you need two different parameters here, and I realized this just by looking at the Stack Overflow post, but all data dot group by city. Actually, I don't think I need the brackets. City. And this will now get me the cities in the same order that they were in when we did the group by sum. So that should hopefully work. Look at that, yay. By switching out how we organized our keys, our X values here in the bar chart, we got the right looking chart. So we see that San Francisco is the highest selling, the best performing city of Keith's super duper cool electronics. And as a data scientist, again, I might ask myself some questions. Why is San Francisco so much higher than the other places? Well, this is an electronics store. Maybe it's because Silicon Valley needs more electronics. So, that would be one reason. Maybe the tech to advertise is like better in San Francisco, or more people have more money in San Francisco. I could start kind of creating some hypotheses on the data on why that value is what it is. And same thing for like the lowest values. Like, why is Portland, Maine the smallest? Well, out of all these cities I see here, it's probably the smallest city. Maybe advertising's bad there. You can use this chart to help you really like understand your data and like give key insights to the business people that are going to hopefully improve those sales moving forward. All right, the next question we're going to answer is going to be pretty businessy, and that question is, what time should we display advertisements to maximize the likelihood of the customer buying the product? And so if we remember what our data looks like, it looks like this. And I would say if we're going to use our data to answer this question, what we're going to really need to look at is this order date. And we're going to basically need to figure out a way that we can kind of aggregate all of the order dates into their like distribution over a 24-hour period. So, all right, so how can we do that? So the first option we could do is maybe like parse this like a string, just like we grabbed the month column and just get the first two digits. That could potentially work, but I get a little bit worried about, if this order date changes at all, the format of it, maybe grabbing the hour here doesn't stay exactly the same. So what we're going to do instead is convert this order date into a datetime object. And basically the datetime library in Python allows us to like really easily access different parts of a date, the time, the hour, the minute, in a very like Pythonic fashion. So it will be a lot less hacky than trying to parse this string manually and like try to just hope that the format stays exactly the same. The datetime library, even if this date format changes a bit, it's a pretty smart tool and can kind of do some filling in of the gaps to figure out exactly what part of the date means what. So, I'm saying order date here. I want all data order date to be converted into a datetime object. I think right now it is a string. And so to convert it into a datetime object, we can do pd.toDatetime. So just like earlier in the tutorial, we did pd.toNumeric to convert a row of strings into a row of integers and floats. We can do this to convert this column into a datetime column. And the only potential caveat of doing this is that the datetime format will probably be larger than the string that's probably currently stored in here as far as memory space goes. But I don't think in most cases, as long as your data is, relatively or isn't ginormous, usually the performance here won't be terrible. So I think it's worth doing. So let's run that. Run. And this takes a little while because it is a little bit of a hefty calculation. So once you do this once, though, you don't have to do it again. So it should run quickly again after you've converted that column to date time. Right, and I can show the data again. And, it's changed slightly. Now you see it's in a different syntax. If you really wanted to and wanted to keep the original format, you could have gone ahead and duplicated this column to be like order date and then parentheses date time format or something like that. But I'm fine with replacing it as we did. And so now what is nice about this is if I want to add the hour, because ultimately I might want to group by the hour or maybe the minute, the hour and the minute, I'm going to add an hour column to our data. And it is really simple now that we've converted that column to the date time format. All I have to do is do all data, grab that order date column, and now I have access to doing this dot date syntax. And then once I do the dot date, I can do dot hour. And watch this. So we have like the 8th hour here, the 22nd hour here, the 14th hour here. And now when I run this line, and I'll just show the data after. Look at that. We get 8 here, 22 here, 14 here. It just like knows what part of this date is the hour. So that's pretty cool. And we could also augment this to also do the minute by doing all data, order date, dot date, dot minute. And this type of thing, I keep repeating this in this tutorial. I'm not always remembering this off the top of my head. I am like just trying to find smart ways to work with dates, and it leads me to maybe the documentation that leads me to this, or maybe it leads me to a Stack Overflow that leads me to this. So watch this. Now we got, what did I do? All data, order date. What did I do? Oh, I probably should have an equal sign here. Cool. And look at that. So 846, that becomes 846. So now that we have these two columns, we can go ahead and do some figuring out of the best time. And this is basically a repeat of question 1 and question 2 now. Let's do some group by and then plot some stuff. So similarly as we did in this one, I'm going to use this format to grab our keys. And to start out, I'm going to say that we want to have the hours be hour for our df and all data group by, and then we're going to grab the hour column. So this will be our hours keys that we'll use in our graph. And this time, instead of using the bar chart that we used in the past graphs, I'm going to make this look a little bit more continuous. And I'm going to use a line chart. So we can do that, as long as you've loaded in Matplotlib somewhere in this tutorial already, you can do plot.plot. We have our hours, and then what is our y data? Well, our y data is going to be the result of the all data group by of the hour column. And then we don't actually need to sum up these different values here in these columns. What we can do instead in this case is actually just do a count. Let's see what happens there. What happened? Cool, that looks good. So we did all data group by hour, and then we just counted the number of rows by each hour. So I could, it would be helpful, just real quick, print this out. And you see all of these are the count, which is the number of occurrences of orders for that specific hour. So if we plot it out, as I just kind of had done, we get this nice chart. And so what does this chart tell us? Well, maybe it would be helpful to add some labels. So I'll add a couple labels real quick. So what do we want? So maybe let's make the X ticks the hours, just so we can see each hour easily. So what happens there? So we have all of these tick marks now. One thing that's still tough is it's hard for me to visually see what each tick mark corresponds to on this chart. So what I can also add on this chart is the grid, which is kind of a nice little feature. And that makes it a lot easier for us to actually see which hour probably is the best. So let's look at this. We have peaks at around 11 a.m. or 1100, 11 a.m., however you speak your times. And then another peak at around 19, so about 7 p.m. So 11 a.m. and 7 p.m., that kind of makes sense. It's like, early in the day, you're doing your chores, or like 7 p.m. makes sense. Maybe it's after work type of deal. So those are the peak times that people make orders. So if I was to answer this question, I would say, we should probably, if we're to advertise effectively, what is the question asking? What time should we display advertisements to maximize likelihood of customers buying? I would say this chart kind of shows us that, maybe right before 11 a.m. is a good time to put an ad, or 12 is a good time to put an ad, or 6 p.m. or 7 p.m., 18 or 19 here would be good times to display ads, because those are the peaks of when all the orders in our data set happened. And we could label this chart the same way we did for the other ones if we want to. So I could do like cool, that looks pretty good to me. And this is something you could present to a business person and say, hey, look at this data. This is from the past year. Let's target our ads at this time and this time. And maybe you would break it down a little bit further, because this chart was for the every city. Maybe you could do specific charts for certain cities. It's all stuff worth playing around with. All right, the next question is, what products are most often sold together? So feel free to pause the video and try to solve this on your own. I will note that I thought this was a particularly hard question, so kudos to you if you can solve it without seeing my solution. All right, so how would I go about solving this? And I guess to introduce the problem, the first thing to note is, how do we know if a product is sold together with another product? Well, if you look at these order ID values, I guess we do get to see one right here. If they have the same order ID, then that means that this Google phone and these wired headphones were ordered together, because they have the same order ID and they also are delivered, as you can see, to the same address. So basically, we're trying to figure out, counting all of the duplicate order IDs, which products were sold together the most. And yeah, as I said, I didn't think that this was particularly easy. I thought this was pretty challenging. So don't worry if you couldn't get this one on your own, because I was scouring Stack Overflow to just figure it out myself, and I was the one that asked the question. So, all right, so how would I do it? Well, the first thing is, I wanted to know, we want to know all of the spots in our data frame, I guess, that have duplicate rows, because those are the only rows we need to worry about that have duplicate order IDs, because that will ultimately let us find which products were sold together. So let's create a new data frame for this. And we're going to take our all data, and we're going to filter by all data, order ID, and then do .duplicated. So this will check all the rows, or all the cells in the order ID column, and see which ones are duplicated. And then we're going to pass in this keep equals false. So I'm going to now show you what this data frame looks like. And we'll pass in, let's say, 20 values here. As you can see, this and this have the same order ID, this and this have the same order ID, this and this. Sometimes you'll see like 3 values. It's possible that you had 3 values that were all ordered together. But yeah, it just stripped that big all data frame down into just the duplicate one. So we can work with this data frame now to do the additional stuff. And I think in the final kind of solution Jupyter Notebook that I have, I'll reference what Stack Overflow links I used here. And another helpful trick is that if you're like, you kind of understand this command, but you don't understand why I passed keep equals false here. If you're using a Jupyter Notebook, at the end of the column that was run, you can do Shift Tab, and it opens up the doc strings for it. So you see this keep parameter, and if I expand this, keep is basically whether or not you should just keep the first occurrence of the duplicate, if you should keep the last occurrence of the duplicate, or if you should keep all as all duplicates, and that's why we passed in false, because we want to keep everything. All right, so what do we do now that we have all of these duplicates? Well, we need to start like grouping them together. So I'm going to create a new column in our data frame, and I'm going to call it grouped. And this is where some funky stuff's going to happen, where I basically want to create a new column that's going to have Google phone and wired headphones on the same line. So that's when you see the magic that I'm about to put on the screen, that's ultimately what I'm trying to get at is, instead of having these on different lines, let's get them all on the same line. And so to do that, we're going to add a column called grouped, and we're going to group by the order ID now from our filtered df, that's the only the duplicated rows. So we have our order ID. And then what we're specifically looking at within the order ID is the product column. And then we're going to use a function called transform. And transform is similar to like apply, where it takes in like lambda x if you want to edit actual cell contents. And so for all of the order IDs grouped by product that are grouped together, we're going to, for each one of those x's, we're going to do some joining. So we're going to join them by, I'm going to say commas. So what does this now look like? Hopefully that worked. We'll see. Maybe this takes a little while. Cool. It looks like it worked. Yeah. And yeah, read whatever this is saying. I'm not sure quite what's happening. It's telling me to use loc, so I maybe should be using loc somewhere, but it is all working. You see that we have Google phone, comma, wired headphones here in the grouped column. So that looks good. And now let's think. The one issue I do have is that we have this same order twice because we did this in every situation in the group by. So we have 2 and 3 that are exactly the same. So let's drop out those duplicated occurrences of the same order, like the same pairs in the order. So we're going to get rid of duplicates here. And to do that, we can do df equals df. We're going to just worry about the order ID and the grouped values. And because otherwise some of this other stuff might be different, like if we accidentally take the index, but we probably don't have to filter it exactly like this, but we'll take those two columns and drop the duplicates. All right, so what do we get now if I do df.head? Oh, this was supposed to be drop duplicates like this. Cool, that looks good to me. We have, like, as we saw before, this one now only occurs a single time. So when we're actually counting these up, when we're iterating over all the rows and our final, this df we can now use like pretty, I don't want 100, that was a lot. But basically we're gonna iterate over all these rows and count these pairs now and use that to get our final count of what products are sold most often together. Okay, so let's move to another cell to do this last part. Okay, so we have a data frame that looks like this. And so now we need to count the pairs of what occurs together most frequently. And we're going to use a couple new libraries for this. We're going to import itertools. From itertools, we're going to import combinations. And from collections, we're going to import counter. And as I said before, in these columns, in these cells, when you look at the final solution for this, I'll have pasted in there, as you see I just did with this one, the Stack Overflow post that I looked at when I was doing this. But okay, so how do we do this? Well, basically, yeah, I looked at this Stack Overflow post, so I can reference this one and see kind of how we can use it to help us. All right, so let's look at the Stack Overflow post. We have a list of comma-separated values we can kind of think about. Like we could probably convert that grouped column we have into a form like this, but we have a list of lists that have that, and then we update the count based on the combinations in the sublist. So if we can just duplicate this format, then we can do what we want and ultimately get a dictionary out like this. So let's do that real quick. Well, the first part of that answer was to have a counter. So we do counter. And then it was for sublist and list. Basically, we had to iterate through. So we want to use this as our sublist. Well, to do that, we can do for row in group, or the data frame in the grouped column. And so this will now get us each one of these entries. Okay, so now we want to get a list, because in that original Stack Overflow post we had a sublist. So the row list, we could do a row.split on the comma and get a sublist, which is kind of nice. Then we can copy the format with counter with our own variable names. So that would be count.update, update, counter, combinations, row list, and then we want to count pairs of 2. So if you wanted to count like the most common 3-way occurrences, you could do you may pass in 3 here. So we now have that counter. So if I print count, I think we should see something nice. That's pretty messy. But I think it does tell us what's the first thing. iPhone and a lightning charging cable. Those were the the items that were most commonly ordered together. But if we want a nicer formatting of this, we could do count.mostcommon 10. This went with a counter object. There's a most common method, and that should, yeah, that's a little bit nicer, where we can see the pairs in a more readable fashion. And if we want to get even more readable from that, we could do for key value in count most common, and then print just key comma value, and that will give us this, which is, I guess, a little bit easier to read. And I'm actually just curious real quick, would we get the most common 3 in a row if we did the 3 here? Oh, look at that. So if you wanted to see the most items that were most commonly sold as 3 items together, you do pass the 3 in here, but we'll keep that as a 2. And that's pretty cool. And so what would we do with this? Well, maybe you try to be smart with promotions that you're offering. If you're selling an iPhone, maybe like try to offer a smart deal so you get more people. People already probably want to buy an extra lightning charging cable, but maybe you do a smart deal where you can kind of lure in an even bigger audience to buy that lightning charger cable. And you can kind of repeat that with these other common pairs and maybe try to use that to your advantage as a business user. So this data would help a business kind of make decisions like that. All right, let's end this video with one last question. And this final question will just be a little bit definitely simpler than the last one. And it's going to be, what product sold the most and why do you think it sold the most? Okay, so how would we go about doing this? Well, we can start off with the same old group by stuff. So all data ahead, let's see here. Data, and really all we have to do to figure out what product sold the most is we need to sum up the quantity ordered based on grouping by the product. So to do that, we can do all data dot group by product. And I'm going to do this slightly different than I have in the past, just to keep things fairly clean. Product group equals all data group by. So if I printed product group, I don't know if it will. It won't do much yet, but if we go ahead and display product group dot sum, we can use the quantity ordered to figure out the best things, and we probably should keep it as a graph again. That's usually the best play. So quantity ordered, if we wanted to abstract it away to a variable, would be equal to product group dot sum and then quantity ordered. All right, and then we can graph it just like we've graphed the ones above. I'm going to make this a bar chart again. So I'll take maybe this. So products, we'll say product for product df, and this would be, instead of this, the product group. What happened? Oh, I spelled wrong. No, spelled wrong again. All right, and now we want to plot dot bar. Our x will be the products, and our y will be the quantity ordered. That looks good. Oh, look at those labels. Those are pretty. Let's do the rotation that we did in the one of the last examples. I'll just paste that in. Keys is, oh, I pasted it in from the wrong spot. And look at that. You got a nicer looking graph there. And if you want to get rid of this annoying stuff that comes before and you're using Jupyter Notebook, just do the plot.show. Look at that. Okay, and now probably should add a label if we want to. Plot.ylabel equals quantity, or just number ordered. And then the quantity ordered, I guess it probably would be better as quantity ordered. It is taking into account the fact that you might order two of the same product, and that's all summed up into this. And then our X label was product. Okay, so now that we have this graph, the question originally was, what product sold the most and why do you think it sold the most? Well, we can see that AAA batteries were the most hot item at the Keith's Fancy Smancy electronics store. Immediately, maybe you have a gut feeling on why it might be sold the most. Let's see the other items that are sold the most: the lightning charging cable, the USB-C charging cable, wired headphones, AA batteries. And why would that be sold more than like an LG dryer, an LG washing machine? Well, the immediate reaction that I have when looking at this data is that those items are cheap, like AAA batteries, and LG dryer is not cheap. So that's probably the reason why this is a lot higher than the other ones. But, as data scientists, it's often good to prove our hypotheses. So what we could do is overlay this graph with maybe the actual prices of these items and see if there is that kind of direct correlation. Okay, so let's make a new cell to do this. All right, to start off, let's get the prices. And so to do that, we could group by the product. And in addition to sum and count that you've seen in this video, there's also .mean. And what will we want the mean of? Well, we want the price each. That will be kind of the average price these things sold for. Price each. Okay, so let's print out prices. And look at that. You got all the prices of these objects. That's pretty straightforward. Okay, so now that we have that, now we need to figure out how do we overlay this data on a chart into this graph and add a secondary y-axis, I guess, that would be the price over here on the right, but keep the same x labels. So as we've done in several times throughout this video, let's use our handy dandy friend, the internet, to help us out in doing this. So we want to add a second y-axis to a Matplotlib chart. And let's see what we get when we query this. Okay, so a second y-axis to Matplotlib chart. You get one post here. The top result is from matplotlib.org. And oftentimes, matplotlib.org does some good stuff. But oftentimes, I usually find the easiest solutions come with Stack Overflow posts. So I'm going to take the first one here. And see if I can adapt what the answer is to what I'm trying to do. So the question is adding a y-axis label to a secondary y-axis in Matplotlib. And this answer that has a lot of upvotes, and I always am kind of judging the upvotes to make sure it seems pretty liked by a lot of people. It uses this fig ax1 plot.subplot. So we're going to want to use subplots, and I think basically we could probably copy this code pretty exact and then just adapt it to what we need. So I'm going to do that. So paste in all of this. And so instead of plotting x and y1 like they have, we'll ultimately plot what we use as our x and y data. So in both cases, our x data is going to be the products, so we can pass that in as our x. Pass it in as our x. Okay, so this first graph, we could take the bar chart. Instead of doing a plot here, let's do the bar chart that we had before. And actually, we can probably just take this exactly. So basically, replacing the y label with the quantity ordered like we had before. And then over here, x2. Well, that is going to, and sorry, this should not be plot bar. This should be x1.bar. I shouldn't have changed that. Okay. x2 to plot products, y2. y2 is now our prices. And this p minus, that's going to be how the line is displayed of the line chart. So we could keep that. We might play around with that in a sec. Set x label. Well, our x label is the same for both our y's, and that's the product name. The y label will be the first line label that's associated with the bar chart is quantity ordered. And the second y label is price. And we could say in US dollars if we want to, but I'll just do price here. Okay, let's hope that this works. Hey, look at that. It's still a little bit ugly. Here's a little thing that I already had written down because this was a little bit tricky, but we can set the xtick labels with the axis using this format. It's a little bit different than plot.xticks, but that should do the rotation that we've been doing. Look at that. Cool, cool. And then we should just get the price to sync up, the colors to sync up. So the quantity ordered has a color green here. So let's also pass this in as color green. Okay, cool. So now we have a chart that's overlaid, or a graph that's overlaid on another graph. In the blue, we have the price. And in the green, we have the quantity ordered. So if the price and the quantity ordered kind of like correlate, and that's kind of, we're trying to like prove our hypothesis. Whenever the quantity ordered is high, this should be low. And as we see, that is the case for the AAA and AA batteries. As we go to the other products like LG dryer, that's pretty dang expensive, and it makes sense that it caused it to be low over here. And then you look at some inconsistencies with that. Like you might say, hey, the price is very high for the MacBook Pro laptop and the ThinkPad laptop. why is the quantity order, like it's so much higher than the LG dryer and LG washing machine? Well, you know, I guess more people are looking to buy MacBook Pros. You know, there's more students in the world. There's more demand for MacBook Pros. So this overlay can't tell us everything, but I would say it is pretty good evidence for why like the AA and AAA batteries are so high, the Lightning charging cable is so high, the USB-C charging cable is so high. Those are such low prices that the demand, like the quantity ordered, ultimately shoots up because more people are willing to pay that price. All right, with that, we're going to end the video here. Hopefully you guys learned something and also had fun with this tutorial. I know I had a lot of fun personally making this tutorial, from curating the data to asking business questions to using the data to analyze those questions. So hopefully you also enjoyed that process. If you did enjoy this video, it'd mean a lot to me if you throw it a big thumbs up. I want to make more videos like this in the future, but the only way that I'm going to know to do that is if you guys show interest in this one. So throwing a big a thumbs up would mean a lot. Also, while you're at it, subscribe. And if you want to more up to date on what I'm doing, day in, day out, check out my Instagram and Twitter. All right, till the next video. Thanks again, guys, for watching. Peace out.